Okay, let me start. Question 2. A surveyor measures the dimension of the room constant heat. Yes. Figure 2.1 is a top of view of the room and so the measurement taken. Okay, this is length of this point. No. Okay. State an instrument that will be suitable to take this measurement. Instrument that will to take this measurement. Maksudnya apa nih ya? Instrumen yang sesuai untuk mengukur ini. Meter rule ya. Maybe meter rule maksudnya alat ya ini. Meter rule. Meteran ya. Then question B. The volume at the air on the room is 76.4 meter cubic. The density of air 1.2 kilogram meter power 3. Calculate the mass of the air in the room. This is relationship between density and then volume. They need about mass. Yeah. We use rho. Yeah, rho is mass over volume. So when we find mass, this is something with density times volume. Yeah. The density is 1.2 and volume is 76.4. So we have 1.2 times 76.4. This is equal 91.68. Yeah. Maybe if we round it in three significant figure, this is something with 91.7. Yeah, in kilogram. That's it. Yeah. We use the formula. This is the basic formula of density. Yeah, basic formula density. And we get mass of this air is 91.7 in kilogram. Yeah, that's it. Okay, no, a window in the room is open. The next day, the temperature of the room has increased, but the pressure of the air has stayed the same. State and explain what happened, the mass of the air in the room. Okay, actually, this is about kinetic theory of gas. Yeah, if the gas rise the temperature, so it will be rise also, but volume. Yeah. State and explain what happened, the mass of the mass. Yeah, mass is constant. Yeah, mass is constant. Mass is constant, but the distance of mass. Yeah, the distance of mass. Yeah, or let's say this is particles. Yeah, a little bit far. Yeah, apa namanya agak sedikit have far distance. Yeah, far distance. This is like if you draw it. Yeah, when this is like a gas. Yeah. Let's say the first condition is like this one. Yeah, still near. Yeah, and they have velocity. Yeah, maybe on grade 12 we will learn more about this one. Yeah, so if they have more temperature. Yeah, or temperature of the room has increased. The first one is the velocity of the mass particle is a little bit increase, yeah, increases too. So the distance between particle is more far. Yeah. Well, that's it. Ini akan lebih jauh ya dengan velocity lebih bertambah. Tapi ini nanti akan lebih dalam kita pelajari di kelas 12 ya tentang partikel, gas particle. Okay, number 3, figure 3.1 shows an oil can containing only air 8 atmosphere pressure. Oh, only air ya. Containing air. Atmospheric pressure is 1.0 times 10 to the power 5 Pascal. Then, oh, we have some question here. Yeah. The pressure of the air in the can is reduced by means of a pump. Yeah. The can collapses when the pressure in the air the can falls to 6,000 Pascal. Yeah. Explain why the can collapse. Oh, this is because maximum pressure ya. Pressure means ini yang kemarin Papa. This is like because the particle gas particle like hit the wall of the wall kan kayak dia menubuk dindingnya dan dia maksimum adalah di 6,000 Pascal ya. Okay, 10 question II. The surface area of face X on the can is 0.12 meters squared. Calculate the result force on the X when the can collapse. Okay, when the can collapse, the pressure is 6,000 Pascal. Yeah. So the force is when collapse, this is equals to P times A. So collapse in 6,000 Pascal, and then A is 0.12 meters squared. So this is something with 720 Newton. 720 Newton. 720 Newton. That's it. On the next page, we have B. Oh, what is it? Okay, we read first here. B question is: mercury is poured into U-shaped glass tube. Water is then poured into one of the limbs of the tube. Oil is poured into the other limb until the surfaces on the mercury are at same level in both limbs. Okay, figure 32 show the result. Okay, you see this. This is between three fluids. This is oil on the left one, and then water on the right one, and then on the middle is mercury. They have height of the oil from this level. This is same level. On the top of mercury, this is same level. 0.32 meter for the oil and 0.25 meter for the water. So, question I: state and condition that must be true in order to the mercury surfaces to be at the same level in both limbs of the tube. This is actually why is same, because the pressure of the oil and water is same, so like equilibrium, force or maybe pressure by oil equals to pressure by water on the mercury. So this is the answer, yeah. Pressure between oil and water are same, ya, because some level, ya. Karena same level ini dia menyebabkan itu dikatakan sebagai pressure-nya sama, ya. Okay, now and then question I move down, ya. I move down to see the question. Okay, the height of a water column is 0.25 meter. The height of oil column is 0.32 meter. The density of water is 1000 kilogram per meter cubic. Calculate, we have two questions here. The first one is about, question one is the pressure exerted by the water. So pressure by water, PW, let's say. Yeah. This is something with rho GH. Yeah. Rho density of water is 1000. Gravitational acceleration or free fall gravity, we use 10 here to make it easy. And H is water, they have height is 0.25. 0.25. So same thing, this is a fourth of 2500, yeah, 2500 Newton per meter square. Yeah. Okay, this is P water, so H water, and this is rho water. Yeah. Okay, done for the question one. Yeah. Yes.
Tapi kalau buat gravity pakai 9.8 boleh kan?
Boleh. Ya, ini untuk make it easy aja. Okay, the density of oil. Now density of oil. After we know pressure of water. Yeah. The next question about density of oil. So what I mentioned before, the pressure between oil and water are same. Yeah. So we will use this. Yeah. P water. This is something with P oil. When we put it raw water, G and high water, same thing with raw oil, yeah. G and H of oil. So sometimes we use like this one, yeah. Hydrostatic law, that P water times H water, same thing with P raw oil, yeah, density oil times H of oil. Ya, so gini saja. Ini raw water adalah 1000 and times H of water is 0.25, and then S equals to raw oil times H oil is 0.32. So density of oil is 250 divided 0.32. 250 divided 0.32. This is 781.25. 708 in kilogram meter kubiknya. Question 4. Figure 4.1 shows a small wind turbine used to generate electricity. Okay. This is turbine, yeah, from the air, yeah, from the wind. The wind turbine drives an electric generator. The wind blows a velocity 7.0 meter per second at right angle. Yes, this is the maximum. Yeah, on the right angle is maximum. To the plane of the turbine, yeah, the mass of uh, air passing per second per detik through the turbine is 6.7 kilogram. Calculate the kinetic energy of the air blown through the turbine per second. Wow. Okay, kinetic energy. I think you still remember. Yeah. This is a half mass time velocity square. Yeah. A half mass is 6.7. Yeah, 6.7, and then velocity is 7.0 square. So I calculate first ya. 6,7 kali 49 bagi 2. 164,15 ya. If you run off this number ya, 164 joules. Ya. That's it. Ya. Ini harus hafal ya, kinetic energy. Pasti udah hafal sih dari dulu ya. Okay, so the power output. Let me check. Only 80% of energy is converted into electrical energy. Calculate the power output of the electric generator. Okay, this one. Efficiency. Yeah, this is efficiency. Hydrocorsia. Efficiency or the symbol is in ya. Kita baca ini adalah eta ya. Efficiency is power output divided power input times 100%. So it means ya 80% is this one ya. 80%, 80 80% is P output divided P input. Okay, this is per second ya, turbine per second. Yeah. It means joule. Yeah. This is like 164. This is already per second. Yeah. Per second means as the power. This is something with power 2. Yeah. This is something with power. So we can use this 164 watt. Yeah. Or we don't need put about the apa namanya unit. Kita nggak usah masukkan unit saja. Ini pengertiannya sudah 164 gitu, times 100%. Okay, so P output kita bisa cancel ini ya. Ini jadi 0.8 like 164 times 0.08. Nah, coba. So, dikali 0,13 yeah, maybe 13 yeah, or we round it 13 watt yeah. Okay, this is 13 watt yeah. And here is 164 joules. Okay, that's it. This is intermezzo about energy and efficiency. Yeah, this is the formula of efficiency. Yeah. Okay, this is about density. Yeah. The volume of air passing through The turbine each second is 5.6 meter cubic. Yeah. Flow rate is 56 meter cubic per second. Yeah. Calculate the density of the air. Again, the density is mass over volume. Yeah. Uh, Here, yeah. Density or rho is mass over volume. So we have mass is this one 6.7, yeah, 6.7 kilogram. 6.7 kilogram. The volume is 5.6. Yeah. So the density is 6.7 divided. Yeah, we have 1.19 or maybe 1.2. Yeah, this is about 1.2. Yeah, in kilogram meter cubic. Yeah, that's it. Still use this one. Yeah. Okay, then the second one, question C. Yeah. Oh, what is it? The turbine is termed a generator. Yeah. Describe the essential action with generator produces electricity. Oh, actually, yes. You didn't yet learn about this yet. But if I draw it, yeah, this is why generator that produce electricity by electromagnetic induction. Yeah, this is from the apa namanya tadi Bapak lupa. This is from wind, ya, generate apa namanya baling-baling apa ya namanya. Oke gini, this is from kinetic energy, ya, kinetic energy change to electromagnetic induction. Become electricity. Or maybe kalau Bapak bikin flowchart, this is kinetic energy and this is electricity. Yeah, electricity. Kurang besar. Yeah, this is in here is we have electromagnetic induction. Electromagnetic induction. Yeah. On this side, yeah. This is from wine, yeah. And this is maybe go to household wiring. Household. Ke rumah tangga, alat listrik rumah tangga ya. Nah, and then electromagnetic induction we will learn about this probably in grade 12, grade 12 ya, semester 1. We check question 6 here. This is about pressure and force also and about density. Question 6, figure 3.1 shows a house brick dimension 21.0 centimeter times 10 to the 10.0 centimeter times 7.0 centimeter. Okay, this is brick ya, kayak batu bata ya. Tapi gede 7 ya. The brick is held underwater. Ini harus diingat nih. Di dalam air ya, on the water. Which largest surface horizontal? Yeah, density of water is 1000. Calculate the differences in pressure between the top and bottom surface of the brick. Top and bottom, yeah, the difference is pressure is like delta P. Ya, ini gini ya. Sorry. P actually rho G H. So when we talking about delta P, this is rho G, this is delta H. Yeah, delta H means 7. Yeah, because like this is like H2 and this is H1 gitu. This is delta H ya. So here is delta H. Kayak gitu ya. Sebenarnya sama dengan 7 juga ya. Ini H. So delta P rho, because this is held underwater, rho is raw water 1000, and G, let's say we use 10 ya, and this is 7. Remember, this is in centimeter. We need to convert into meter, yeah, times 10 to the power 2. Okay, so this is 700 Pascal or Newton per meter square. Okay, this one. Same thing actually with this one. The answer is 700 Pascal. Pressure difference. Then A question done. B question. This is A question. Yeah. The answer is 700 Pascal. B question is about use value from A, 700 Pascal, to calculate the upward force exerted on the brick on the water. Okay, this B, yeah. We need to find force, yeah, and we'll use a formula of force by using relationship between pressure, yeah. Force equals to pressure times area. Pressure is 700 Pascal, and then area is this one, upward force. Yeah, it means like the area or the force is like on here. Yeah, so this is force. Ketutup. Artinya sebenarnya Bapak ketutup. Force. Yeah, the area is about 10 and 21. Yeah, in we need to change. We need to convert into meter to. Yeah, ini times. Oh my god, sorry. Times, yeah. The area is 10 times 10 power minus 2, and then this is again 21, yeah, times 10 power minus 2 also, yeah. So we get ini jadi hilang. Oh, only 21.0 Newton. Oh, sorry, dikali 7. Ini kan 10 power minus 4, jadi hilang 1, 2, 3. Kita kali aja 7 kali 2,1, 14,7 or 14.7 Newton. Yeah, that's it. Use the formula this one, F equals to PA, and we get the answer is about 14.7 Newton. Okay, again, if you want to copy, oh ini masih ada lagi sih bawah sini ya. Tanggung ya guys ya. Satu lagi deh, ya. Nanti setelah itu ya pas. This is already 11:24. Akan sergeser dulu ini. Nah, seperti ini kelihatan. Okay, we check question C. One more question. The mass of brick 3.0 kilogram. Yeah, calculate the acceleration brick when it's released. Oh my god. Oh, we use, actually this is like different with our topic ya. You still remember about Newton's second law is force equals to mass times A. Yeah. So A equals to mass of force divided M. Yeah. Force we have 14.7. Then mass is 3.09. So we have acceleration is 14.7 divided 3.09. Okay, 4.76, yeah. I round off this about 4.76 in meter per second square. Yep.
Itu yang di atas itu yang for
Yang mana? Ke atas?
A sama, yang buat A sama B itu 10 to the power of negative 2-nya dari mana?
A sama, centimeter, change into meter, convert.
Convert.
Okay. Convert into meter. Okay.